Okay, we're just going to have a look at the last little bit on cubic graphs. So first one, cubic graphs with one x-intercept but no stationary point of inflection. So basically we get to a stage or some circumstances where we find one linear factor, and then we have a quadratic and we can't factorize that quadratic any further into intercept form. Okay, x squared plus x plus 3, well there's no really two factors that we can multiply together to get 3 that add up to 1. Same thing for this example, we have x take 4 as one factor, that's all well and good, but this quadratic, again, same, we can't factorise it any further, which causes problems when we try to draw the graph. Now in most cases, if you get to a stage like this, basically your calculator is your best point of call there. There's no real simple way of graphing this equation as something like this. So using your calculator, you'll get two graphs that look like this. So first one, x plus 1, x squared plus x plus 3, looks like this. Okay, we've got no stationary point of inflection, but we've got 1 point of x-intercept. The other one, okay, goes a bit up and down, and there's again no stationary point of inflection, but we've got one x-intercept, one y-intercept, and we'll look at finding the turning points later on, but at the moment, calculator is our best friend there. Okay, let's just have a look at this bit. So we've got cubic graphs with 3 x-intercepts. So for the graph of a cubic polynomial to have 3 x-intercepts, the polynomial must have 3 distinct linear factors. And this is what I was trying to talk about before. So remember this example where we had to factorise this equation, and we found the first linear factor of x take 1, and then we got a quadratic. It was x squared take x take 6. Okay, using our factor theorem from a few videos earlier. Now we can actually go further like we did before to get 3 linear factors. So x squared take x plus 6 we can actually factorise as x take 3 and x plus 2. Minus 3 times, that should be, minus 3 times 2 gives us minus 6, minus 3 plus 2 gives us minus 1. So we get 3 linear factors. Well, these are actually all our zeros, or our x-intercepts. Like our quadratics, when we use the null factor law, we can say x take 1 equals 0, or x take 3 equals 0, or x plus 2 equals 0, and solve for those. So we'll have x equals 1, x equals 3, x equals minus 2. And then when we put it on the graph, okay, 1, that occurs here, 3, about there, and 2, somewhere there. So 1, 3, and 2. Okay, now there are our 3 x-intercepts, basically. Now we can say, basically connect the dots almost. So just have a think about it, like before, okay, using our key features. A greater than 0, okay, number in front of x cubed is our A term. It's greater than 0, so it starts below the x-axis. So it starts below, here's our first term, so there we go. It's going to look something like that. Now I could find the y-intercept, again we'll look at finding turning points later on, but at this stage just look at the x-intercepts. Okay, so we've got, that should be a minus 2, positive 1 and 3, and that's what the graph looks like. So in summary, we can actually say that if we have, so this is our x, if we have 3 points, A, B and C, three x-intercepts, okay, and our graph looks like that. Then our equation, y equals x take A, x take B, and x take C. Okay, these are going to be our x-intercepts. Similarly for the reflection of that, so if we've got same points A, B and C, but the graph goes like this, just means that we've got a negative in front. X take A, x take B, x take C. Same thing, except we've got a negative and it goes the opposite way. So that's a summary of three x-intercepts. And we'll have a look at the next bit for an example.